Algebra. We're going to do lesson 4.4 today. This lesson starts off with a review of common logs. So a common log is any logarithm that has a base of 10. This is the log key that you see on your calculator. So when it says log on your calculator, that is base 10. Just like when you see the ln, that is log base e. So base 10 is called just a common log. And for all of these, you're going to just be putting them right into your calculator. We're going to round to 4 decimal places. Now, if you type in the log of 10,000, that's going to come out to be 4. Now, a quick way to do powers of 10, log base 10 of 10,000 means 10 to some power is 10,000. Well, 10 to the 4th power is 4. So log base or log of 10,000 would be 4. If you just simply count the zeros, that would be the answer. So applying that to the log of 100, that would be 2 zeros. Log of 1,000,000 would be 6. So powers of 10 are going to be super easy and you don't need a calculator. The log of 341. So I type that into my calculator and about 2.5328. Okay. One of the common applications we have for logarithms is the pH of a solution. So the formula is on page 450 in your book. It says the pH is the negative log of the hydronium ion concentration. Part A, find the pH of a solution with H3O positive of 6.8 times 10 to the negative 8. So what we're going to do is we're going to take and put that right into our calculator. It's the negative log of 6.8 times 10 to the negative 8. Let's go ahead and put that in. And with a pH, you can round that to 1 decimal place, so that's about 7.2. All right, now we're going to work backwards and we're going to find the H3O positive when the pH is 4.3. All right, the way we do that is we switch it to an exponential. We know when we see the word log, it's base 10. So we're going to do 10 to the 4.3 equals, oh, I messed up. Let me fix this real quick. You need to move the negative to the other side first. So negative 4.3 equals log of H3O positive. And then switch it to an exponential. So log base 10, so 10 to the negative 4.3 equals H3O positive. Now a common way to write this answer is in scientific notation. So my calculator automatically puts it in scientific notation. Yours might not. There it is. Okay. The next one that we have is loudness of sound. It's on page 451. So basically, decibels are figured out by taking 10 times the log of a sound's intensity divided by the threshold intensity. And your book describes threshold intensity as the intensity of the faintest sound that can be heard. Find the decibel rating of a sound with an intensity of 10 million I of 0. So the sound that you're hearing is 10 million times greater than the faintest sound that can be picked up with your ears. So we're going to find its decibels. So the intensity is 10 million I of 0. And we're going to divide that by I of 0 because that's what the formula says. So what I've done here, this is I, and I plug that right into my formula right there. Now these are going to cancel. And we had that discussion earlier about counting the zeros for a logarithm of a power of 10. 10 million has 7 zeros, so this is going to be 10 times 7, which is 70. So that sound has a rating of 70 decibels. Okay, we talked about this just a little bit ago. When you have a natural log, that is log base e. And so what we're going to practice now is just putting those into our calculator. The ln of the natural log of 341 is about 5.8319. A nice fact to know is that the ln of e is 1. I would memorize that. That's going to help you with some problems. So if I'm doing b, I can take the exponent of 4 and I can put it right in front using our power rule from lesson 4.2. So once I bring the 4 down to the front, I'm sorry, that might have been lesson 4.3. But anyway, I bring the 4 to the front. I'll get the answer of 4. If I take the logarithm or the natural log of a decimal that's smaller than 1, I'll get a negative result, and I'm going to see that here in this next example. So negative 2.6745. Excuse me. On D, I can type it in the way it is, or I can do the ln of 4 minus the ln of 7. So I can still apply those rules that we had before. Again, you can also just type into your calculator the ln of 4/7. Negative 0.5596. Okay. The last thing we have here is called the change of base. And with change of base, what we're going to do is we're going to be able to find a decimal value for a log with any base. So the idea starts with, okay, if I know log base 4 of 4 is 1, and that's from one of the rules that we had in lesson 4.3, because 4 to the first is 4. What would log base 4 of 15 be? So if I took 4 to a power, what would it be? What power would that be to get 15 as an answer? Well, we know that 4 squared is 16, so we know our decimal value has to be somewhere between 1 and 2, probably closer to 2. And so change of base is going to allow you to find that. So if I were finding log base 4 of 15, I would simply put the log of x over the log of a. So what I tell students, so they don't get this backwards, is you're just going to take the log over the log, and the base, which is 4, goes in the basement. So it's base in the basement. So you got to know that 4 is the base. If you type that into your calculator, so log of 15 divided by log of 4, you'll have approximately 1.9534. Now, another thing you can look at here, this would also work if you did the ln of, the ln of 15 over the ln of 4. So it works with logs or natural logs as long as you use the same one. And so we're just going to practice that here. Log of 20 over log of 5. And just to be different on this one, I'm going to do the natural log of 0.7 over the natural log of 2. I'm going to put both of those into my calculator. (1.8614). And then the ln of 7.7 divided by the ln of 2. Oops, I think I entered that one incorrectly into my calculator. It's important to close those parentheses after each argument. Okay, negative 0.5146. That's it for this lesson. So the notes were nice and short for this lesson. We're going to move into lesson 4 or 5 next, and that one will be solving equations. So we'll spend the most time on that lesson in this chapter. Stay tuned for more. Have a good day, you guys. I miss you. Bye.